Okay, hope your ears didn't die. So today back to hard problems. Problem 624 game. You are given an integer array cards of length 4. You have 4 cards, each containing a number in the range 1 through 9. Change the numbers on these cards in a mathematical expression using the operators blah blah and parentheses to get value 24. The division operator represents real division, not integer division. That's interesting. Every operation is between two numbers. In particular, we cannot use unary operator. You cannot concatenate numbers together. Okay. Okay, that's interesting topic. I mean, not so much. This is not a great problem, but whatever. Maybe tomorrow. So, my first thought is that if we don't have parentheses, can see, okay, so card length is 4 and we have digits. We don't have 0. First thought, if we don't have parentheses, we can simply brute force all possible like we can place 3 operators here, so we brute force all possible like we have 4 options for operator here, 4 here, 4 here. That's 4 times 4, 64. Then we just evaluate the expression. Question is if we need to evaluate it ourselves, or I can just use eval function. And another question is that we can give it any order we want, actually. So okay, let's say, so another option is to just brute force all possible positions for parentheses, which many of them are gonna be invalid if we do like start end, like beginning and then we end here, and that's it, that's broken. But we might not have to do that, because that only tells us which operations to do in what order, so we can technically force any order of the operations. So my thought is that we brute force all operator assignments, and for each of them we try each evaluation. So for this we would try first 2 numbers, then second, third, and then third, fourth. And then we try first 2, then these 2, and then join the result. And so yeah, we try all options like this. Now the time complexity of this, and that's interesting, but it's gonna be fairly low, because there is 64 options of operators, and now in how many ways we can try all options. Like let's say we have numbers 1, 2, 3, and 4, and some operators in between. Well, then at first we have 3 options for consecutive pairs of numbers to merge them with the operator. After we do that, we are left with 3 numbers, so we have 2 options. So we just have 6 options of applying operations in some way. So that's 6 times 64 is around 360, so this should be solved in an instant. So let's try it, I guess. Let's try it. So let's make a vector of let's make it private actually. We don't want anything reading it. Let's make it like a constant char array of 4, constant op4 is plus minus times and divide. Okay, and now what we want to do is please turn off the fucking phone. Finally. So 4 const char. Sorry for swearing. So const char op1 in op, and let's copy this op2, and let's copy this op3. And now if equa 24 with this function which checks if given cards and operation 1, operation 2, operation 3, we can get 24. So if that's the case, we return true, and if we did not do it for any combination, we simply return false. Now the function can actually be also in private. Const, no, we don't want const, we actually want this vector int cards, and then const char op1, const char op2, const char op3. Great. Actually, I should send the operators also as an array. So let's do this. Vector char. Great. And then let's do const vector. No. Not const again. Operators. So I'm going to try if we have if cards size is equal to 2. So if we have last 2 elements, then eval, let's call eval pair, which takes cards 0, cards 1, and operation 0. And let's call this long double result. And now if absolute value of result minus 24 is smaller than some epsilon, const double long double epsilon 1 minus 9. what this does is that I simply cannot comparing two flows might not be accurate. So what I do is, instead of doing res is equal to 24, I say the difference between those two numbers is small enough that I can say that the error is for sure just a rounding error. So we return true, else we return false. So because we have two last numbers, and if they can evaluate 24, then cannot get. So now we need to the eval pair long double x long double y char operation if op plus return x plus y, if op y return x minus y, if op is multiplication return x times y, and finally we assume that we always get just those four operations, so return division. Okay, and now we need to try all all possibilities for a JSON pair. So starting index I is more than cards. Okay, let's call it NC, so number of cards int NC is equal to this. Is NCI plus plus. Oh, NC minus 1 actually. And now long double. I don't want actually int cards, I want long double cards. And then if I take long double eval pair cards I plus 1 ops I, so we take the result, and then if equal to 24 with new cards, so we need to construct new cards, so vector int new cards for int j under nc, no, j under I, j plus plus, new cards, push back cards I for so it's two numbers, so then we push new cards, push back result, and then j is equal to I plus 1 plus 2 inc, sorry, j under nc, j plus plus new cards, push back cards I. So we constructed new cards, and then we also need to construct new operations. This should be long double and vector char. So new ops if I0, new ops push back ops 0. Actually, that should be simpler to do. If j doesn't equal I, then push back j, and then we iterate all ops, of which there are nc minus 1, and okay, and then we have, so if the recursion returns true, we return true, and if none of those options return true, we return false. Okay, so what happens? New cards. Vector long double LD cards equals cards. Let's call it LD cards. Okay, that didn't work. For const int card in cards LD cards push back long double card boom. Okay, boom. Wrong answer. I said true. Interesting. Oh, okay. How can you make 24 out of this? I mean 5 minus 1 is 4. I'm not sure how you can make 21 out of this. Salt, cards 0, cards 1, ops 0. Let's use this test case. So 19 and 5, and how you got 19 out of this? Huh? Five and 14. Oh, typo is here. Now it should pass. And now the first one doesn't pass. Bruh. That's weird. So I just try to print what we have. So 4187. So I'm saying false, and you are saying it's not false. So 4187. Let's clear the how should it be possible? 3. Wait. What? I can also have any permutation of numbers? Okay. I mean, fair enough. So we just try all permutations. Do while permutation. So this 24 permutations, so we are at 64 times 6. It's 384 times 24 is like 768, 7,000 plus what's so like 9,000, something like that. So that should run in instant. Cards begin, cards end, boom. That's weird. Maybe I should sort the cards. So sort cards begin, cards which combination? 8471, 8471, and OP1 is equal to minus, and OP2 is equal to multiply, and OP3 is equal to minus. Then only bool print leg. Let's include this print here, and then this says bool print, and if print okay, and we pass print in here. Boom. Should give me something. Says 2. So you tried merging first two, okay, and then you tried merging first two, but why this didn't work out, I don't understand at all. Cards I plus 1. Nah. If print, let's do it like this. So here you consider 8, 4, here you consider 2, 7, and then you had 14 and 1. Let's call this option so that I can see it better. So he considered option 8, 4, then here you consider this, and he finished with 14 minus 1, which is 13, which is not 24. If you consider this option, how you end up with this is beyond me, bro. That is simply beyond me. What is it? So let's check this. How is 7 minus what? Since when is 7 minus 1 7? What the hell, bruh? Okay. So simple typo. Okay. Whatever. Boom. Boom. And this goes to the trash. And then boom and boom. And boom. And boom. Let's see if okay, I have a very slow solution, but I mean, one option is just to see which orders, and maybe I could find some pattern in it, but I'm not sure. Simple. It's just ugly brute force. Try all possible card permutations and all possible operators in between the numbers, and all possible to try all possible parentheses combinations. We simply try all possible orders of applying operators. To try all possible even cards 1, 5, 3, 7 and operations plus, times and minus. We recursively try 6, 3, 7 times and operations times minus cards 1, 15, 7 and operations plus and minus and cards 1, 5, minus 4 and operations plus and times 1 n factorial times 3 to the power of n minus 1. Since we try all permutations of numbers and then we try all possible assignments for the operators, and for each of them it's like times n squared or something. Since we try all permutations of cards, all possible options of operators and all orders of applying the operators. Since n is equal to 4, this runs the entire term. The term is basically a constant. Space complexity is, what extra do we store? Number of cards, and then we recursion 4, so I guess it's like we have to keep these cards and then those cards and then those cards, so O of n squared, since the recursion has a depth of n, and the parameters at each depth take up O of n. Worst case, memory worst case, whatever. something like that. That's worst solution of all time, but this was stupid as hard problem I've ever done. See you tomorrow, hopefully, like, I don't know, graph, DP, anything, please binary search.